duplicate what we have now. It's only an upgrade. We're just going to take what we have, duplicate it with newer technology. In reality, that's not what happens. While we're doing the upgrade, they'll say, well, can't we also optimize what we have so that we actually have some improvement after we've done the upgrade? We're doing the upgrade just to reduce risk because the equipment is out of warranty, it's not in production anymore, we can't get spares. So from a safety perspective and from an operational perspective, we'd like to upgrade the technology. But while we're doing that, let's optimize. We're not going to take the 11 small PLCs that we have and replace them with 11 small PLCs. We'll take the 11 small PLCs, consolidate them into one big CPU, and then have the 11 small PLCs changed to remote I/O racks. Right? So it's not duplicating what we have anymore. Our communication hardware and the protocol will change because we've upgraded the hardware, we've upgraded the software. Now we also need to upgrade the communication that actually goes with it. When we upgrade, we'll have some old stuff and we'll have some new stuff. And then what we assume would work with each other don't work with each other anymore. So now we have to actually go and upgrade some of our other hardware which we assumed would have stayed. While we're at it, because we're now consolidating PLCs, we may also need to upgrade or update our naming convention. Because we're consolidating PLCs, the PLCs that we had in dates back 15 years. We've implemented the standard for our naming convention, but that was 5 years ago. So now we need to conform to that standard with the new upgrade. So it's not duplicating what we have anymore. And while we're at it, this upgrade means that we are going to stop the plant for 3 months. So while we're at it, we are going to exchange some physical plant equipment as well. And maybe we'll even add a new line. The next misconception is it will be a like-for-like replacement. Now, just in terms of the pictures, those pictures are just some examples of what we found when we did control system upgrades. The first picture, everything was neat and tidy, but you'll see things are not neat and tidy anymore. And we find that in a lot of places. So it will be a like-for-like replacement. No, it will not. Sometimes there is no like-for-like replacement available for the upgrade or for the new hardware or for the new software. There is no like-for-like, so you have to change something. Like I said, additional equipment, physical plant equipment will be slipped in as part of the project because we have 3 months downtime. So we're not producing for 3 months, we are going to add equipment or we're going to change equipment that works in a different way. So we have to go and update our control systems because we now have more signals available from the edge that we can utilize in our control system. Because we now have more signals available, we have to consume that information and make it available, make it visual. So we have to go and change the software functions in our plants to accommodate all the new information. The next misconception is that it will be easy because we're not changing anything. That is probably the biggest misconception of them all. Because in reality, everything changes. Because if you're ripping out one part of the control system, you have to retest the whole control system. So from the field, from the actual instrumentation, through the wiring, to your PLC panel, to your MCC, to your SCADA, and to your databases that kind of live on the SCADA, you have to loop check everything, especially if you've changed out PLCs. And I'll go into some additional issues around why that would be required during the project. Then it's also the misconception that a control system upgrade project is an automation project. We're only going to do automation. In reality, it never stays with automation only. The automation is the nice to have. But while we're doing the automation project, we'll add some electrical equipment, we'll add some mechanical equipment, we'll make some changes to the plant because we have downtime or we have time. Those things that's been neglected for the past 5 years, while we're doing this project, we will also fix that. So from a mechanical perspective, from an electrical perspective, we'll fix it while we're doing the software project or the automation project. And in a lot of cases, that's not taken into account during the pre-planning of the project. When you do the design of the software or of the PLC, they don't think about that, and you only find it out when you get to site and you start commissioning. You can see here some controllers hanging off other controllers. That's kind of not, it's bypassing some of the inherent technology that was originally implemented. Which brings you to the next one. And this one bites people all the time. Everything is working as it should now. So when we shut down the plant 3 months ago, everything was working. All the instruments were working, all the contactors were working, all the auxiliaries were working, everything was working. So when you touch this plant of mine, you own it. Everything needs to return to working condition and working order. So in reality, what happens, like in the previous picture, years of short-term fixes that turned into permanent fixes, that's been around, the short-term fix that's been there for the last 10 years, will now need to be fixed. Because we're actually changing the control system, we're upgrading it, and we need to include that into making the system and making the process actually operate as it should. We found that, for instance, people bypass equipment to make the plant run, which is also a short-term fix, but we're getting this intermittent contact on one of our emergency stop buttons. And we can't get the plant to start because this thing trips the whole plant the whole time. So let's just bypass it and we'll fix it tomorrow. And then 10 years later, when you do the project, then you have to fix it because you touched it. That Boermaker plan fixes, right? So we can't get it to work like it should. So we're making a plan. Right? So we're combining some stuff in the PLC, with some stuff in the SCADA, with some stuff in the communication layer, just to get this thing to work. We know it's not standard. We know it doesn't conform to the company standard or to best practice, but that's the only way we could get it to work at the time because the plant's been standing for 3 days at that time. So now we fixed it, and now it becomes a semi-permanent fix for the past 5 years. Then also interlocks. Interlocks commented out in the PLC because the interlock doesn't let my sequence start. And there's something wrong with the field instrument. So we don't replace the field instrument because we don't have a spare. So we bypass the interlock, and now the plant starts up and shuts down as it should, it runs as it should. But there's an interlock missing, and people forget about the interlock being missing. So when you do the upgrade, you follow the standard, and then your sequence doesn't want to start. And then they say, well, your software is broken. or your PLC program is broken. And then you have to first prove that the software is not broken, the PLC program is not broken, the wire to the PLC is not broken, the wire from the PLC to the instrument is not broken, and then you find out, oh, it's the instrument that's faulty, and it has been faulty for the past 5 years. Which brings me to the next one, which is the field devices are all in working order. Everything, when we switched off the plant 3 months ago, 3 weeks ago, everything was working. In reality, it's not always the case. Faulty instruments are bypassed on the plant floor to make the plant run. So the sequences can start up, the plant can produce products, because we've actually bypassed some instruments. We don't have a spare instrument, so we bypassed it, so to get the plant working. So bypass from a physical sense in the field, or from a software sense in the PLC or in the SCADA. This is one of my favorites. The plant's been standing for 3 months. So we have a problem on our 25 level. There's a problem in our motor control center. And now I have to go to surface and I have to go to the workshop to actually go and get spares. But I know just around the corner, there's another part of the plant that's not running at the moment because the control system is being upgraded. So I'll quickly pop into that MCC, take out the contactor that I need, right, and put it in here. Right, so we're pirating from the one part of the plant that's going to be upgraded to supplement the current running plant. But we don't tell anybody, so when the guys come and do commissioning, they have to go first prove that the SCADA is correct, then prove the PLC is correct, then prove that the wiring from the PLC to the instrument is correct, then go, oh, but the contactor in the MCC is faulty. Or it's not there. Somebody took it out. We don't know where it is. And once again, the reason you have to go from SCADA to PLC to field instrument to electrical equipment is you've touched it, therefore you own it. So whatever happens and wherever the fault lies, you have to prove that it is you or not you that is the problem. Because everybody would assume that the person in charge of the upgrade project must have broken something or something has broken during the upgrade. Therefore, they need to prove that they don't need to fix it from their side. Then panel layouts and wiring are standardized. That's also a big myth that we find, because in reality, it's not standardized. There is no panel drawings, because the panel drawings got lost 5 years ago, 10 years ago, when we moved our offices, or when we went into new offices. Or we do have the panel drawings, but they're outdated by 5 to 7 years. We've never updated them. Or we find in the panels that there's some standards, but the standards are not consistent. Each panel has its own standard before the company decided to standardize everything. But everything before that point is not standard. And using different subcontractors, that standard wasn't applied throughout.